Hey everybody, so we're back and I want to show off some kind of cool math, and this is not really a functionality thing just yet, but it is related to something I am working on for the cluster bombs. So I believe I showed off that video previously and said it needed more work. Well, one of the challenges of getting it to work is that it needs to handle yaw and pitch on impact direction to be able to spread out properly. Now what you're looking in front of you is more of a debug version of this, as I've been kind of spending a lot of time trying to get it to work a certain way, and I've ended up going through I don't even know how many different articles. Hold on, so we can find it, and applying basically matrix transformations. So this is a Wolfram Alpha is a good example of how to do this because it actually surprisingly works for Mojang's math, with exception of I believe I had to invert the Y rotation or X. I don't remember which. One of these two had to be inverted. But this is a pain to learn if you haven't gone through it. I skipped trigonometry class in school, so like very annoying to have to figure out exactly how this works, how you multiply them, and how you pass the vectors in, so on and so on. I probably also slept through a little too many classes and so on and so on. But we got the math working. So the math side of this is actually kind of interesting because how it's supposed to work is the missile will go off. This technically could work for bombs and carts and other things, but just this is mostly designed for the missile. It'll get the yaw and pitch. We were grabbing motion because I was planning on applying the motion to the bomblets as well. So you kind of, if the missile is going faster, the bomblets will go faster. And if the missile is going slower, the bomblets go slower. This is going to be disabled for the moment because the missiles go like a couple times the speed of sound when they go towards the target. So really, really fast, and bomblets will then just smack on the ground instantly. I do have this manually set to pitch just because I'm testing it for the moment. But I've got a singular bomblet that shows me what direction the missile was at. This is for testing as well. And then we've got different offsets that we currently apply. When this normally works, what will end up happening is the offsets will be really tiny because it's meant to simulate the bomblets coming out of the missile body and going out in the direction like you would see with a video of an actual cluster ordnance type mission. It then is going to loop by disks. So the disks are right now, they are set by default to 10. I'm hoping to make this customizable so people can do what they want with what they're doing. And I'm hoping to make the count customizable with a upper limit, because if you spawn too many of these, you are going to lag the world. It's just how this works. But it does some cool little math to kind of get the yaw and pitch side of this to work. So by default, we got an offset. We're going to try to go at a 90 of the missile's direction. And this is where it kind of starts getting interesting because of how Minecraft's world works. This is the part where I really want to explain this, because for those other devs who make mods who don't really know this information, they not have actually paid attention to how Minecraft's world space works. So by default, if you are 0, 0, which I'm not going to get perfectly 0, 0, but you can see it on the screen, there are two values that are a bit far down. So if you ignore that top chunk after multiplayer chunk cache, it goes XYZ, blocks, chunk, and then facing. So facing will tell you what direction you're facing, what axis that is, positive, negative, and then it'll go, I believe, yaw first and then pitch. Yeah, it's yaw first and then pitch. So if you go 0, 0, you're going to be facing positive Z, which is south. That's the default orientation that Minecraft assumes for its world space. If you rotate down, it's going in the positive direction for the pitch, up, negative direction. This is a bit weird, but it kind of makes sense when you think of like clockwise rotation. If you were pointing forward and you bent forward, you would be going positive direction rotation-wise, so kind of clockwise, or however you want to think about it, and vice versa for the other direction, you'd be going negative. Its world space continues on this thing where if you're going left, you're going counterclockwise, which means you're going to be rotating towards basically I think it's west. Yeah, west is that direction. Then east will be the positive direction other way. This is kind of important to know because some of the math you'll pick up on how to do rotation matrices may assume a different coordinate space and may assume a different rotation pattern. By right now, I believe Minecraft does not use a roll, so if you try to rotate on the roll, it doesn't exist. In terms of how these are actually done coordinate space-wise, pitch is assumed to be, if I can get my brain remember this correctly, is the x-axis. So imagine there is a, like, say you were holding like a shovel or like a pole across your waist and you were bending forward, you can imagine that's x-axis. And then if you were doing yaw, which is y-axis, imagine you were holding onto a pole and you were rotating around it, or you had like literally a pogo stick at your head, or you were sitting on a chair and you rotate. That's the same way to imagine it. Then roll would be if you had a stick going out from in front of you, or like say like you stuck a dart to your head or something like that, you rotate that way, or you can think of it doing like a cartwheel sideways is a way to think of that direction, which is kind of important to do because we actually do have a rotation helper for this. I've tried to document as much as I could up here for the other ones who want to see how this works and how this behaves and so on and so on. And then we have the different functions. So rotate Y, which is yaw, rotate X, which is pitch, and rotate Z, which is roll. I've also got some clamping code to kind of help, end up with that. Some rotation fixes. You end up some really weird like rounding math from floats. So 0 may not actually be 0. It may be like 0.61 e to the negative 16 because code does that. And if somebody points out Java, I'd be like, every language does it. But yeah, so this all works. I've actually got unit test for it too, which is hilarious to do, by the way, because when you go to test the Z rotation and you do south facing, because you actually have to pass a vector into it, and you by default pass in a vector of south, because south is your default. So south will be represented as 0 on the X, 0 on the Y, and then 1 in order to kind of like calculate that. And then in terms of how this code works itself, I end up pulling these matrices out of this, as long as using tons of other articles to understand how this works. You will have a matrix. The matrix will do cosine sine. This is based on trigonometry. Think of those angles and the tangents and all that stuff. I barely remembered. I had to kind of work my way through this. So you have a matrix, and you're going to take the X, Y, and Z. So it goes by columns. So this will be your X column, this would be your Y column, and this would be your Z column. So you're going to multiply your X. So this would be X of X, this will be X of Y, and this will be X of Z. And you can see that kind of replicated down here because we're kind of ignoring it too. So like if we go based on this column right here, which will then see cosine sine, at least I think it's how I got this here. I may have some values inverted. It may not match perfectly. I just know that after toying around with this for several hours, because I had to like flip these back and forth because Minecraft's axis is inverted, so this may not match up. I'll fix it later. It'll make sense at some point, and I'll get it working. But I do know that it does function enough that we can get the results that I'm kind of expecting, and we can kind of see that kind of with this. So I can launch this right here. But the ideal is as that missile comes in, it'll come in at a certain angle. Now, by default, if it's in the semi-system, it's going to come down with facing 90 degrees pitch downwards. So you're not going to get much of a result in terms of how it spawns. I also do have the motion vectors turned off of this just purely for debugging. But I'll quickly turn them back on just so you guys can see kind of how this looks. So this is now set to 45 degrees, which means it's going to be facing somewhat down. And we can kind of check to make sure that's actually working by looking over in our debug menu and looking at, okay, what's roughly 45? That's roughly 45. So we can check, oh yes, that is actually working. We can also then check my debug one here. This is what I'm using for that. And we can check, did it spread out properly? And of course it actually did. And I've bumped a few of them. So a few of them are off center because like that's actually something that can happen. At least I think that's the case. Yeah, they look right. Okay. And then I have every other rotated by 45, or no, by 90 degrees. So they'll spread out that way. So I can actually change this math. So we can actually go in here, and we should be able to change this to say we want this to face 90 degrees. And if I do ICBM light to get rid of the first one, come in here, and 90 degrees is going to be facing down. So I don't know why I set it to that one, because that one's the default. For most of the sim system. So the sim system, for those who don't know it, is when it goes up and then straight back down. The other version of this is it has an arcing math, which we'll maybe test here in a second. It's a little difficult to set the clusters. So that one works, went straight up and down. We can kind of see as every single one of them is actually facing out. So by default, it's facing out 90. My plan is actually toy with that and get that to face slightly backwards from the missile's direction. That's just kind of give it like more of an arcing flowering effect when it does cluster, so you get a little bit better spread out of them. It'll look nicer too. So we'll change this to a 0. And I'll do ICBM lag again to get rid of the stack. Those are really cool debug stacks. Like, it just looks so nice. It's not how it's actually going to spawn though, but in case that isn't clear. So I'll show you how it's going to spawn here after we get this one tested. And we wait slowly for it to come back down. Probably not my best choice of testing is to use an actual missile. I probably should use some other system. So yeah, there it goes facing sideways. Now what you would use application-wise for this in the actual mod, and if you're in your own game world and server or whatever you're doing, is eventually there will be ways to modify how that missile is facing or the fuse settings, because the two are different applications. So the being able to change the angle will be more of like you're trying to figure out, like you want the missile to still arc towards the target, but as it's coming down the target, maybe you want it to turn 90 degrees and then like shotgun towards the enemy's base instead of hitting directly. And then the timing one will create a similar effect, except that one will be more of either you launched it from a cruise launcher and you're like, okay, after 100 seconds, go off and then clusters in front of it. So maybe you're hitting a wall, you want to cluster barrage a wall or something. There's different applications. It's not always practical in most cases, but it's kind of cool to have that customization ability that these are going to match not only how they would operate in real life, but give different applications how to utilize them. So that does work on that angle. And then let me go ahead and turn off the hard fix pitch because we're using that purely for debug. And we're going to reset it back to normal. And I'm going to turn the normal values back on. So get rid of my debug values. And the idea with how these offsets are designed is it's meant to mimic kind of the size of the missile. So the missile's about 0.5. So technically I could get this offset to be a little higher. So we're going to actually set this to like 0.25. And the stack I'm going to have to probably play with more, but we'll do like that because maybe that will give us enough of visual change that we'll be able to actually see the stack still without it just looking like one amorphous blob of 3D models. Because they'll still look that way. Because remember, you're not supposed to see this visually. They're supposed to project a little too fast, but I need to keep them all in a tight pack because when they come in, they may, if I don't keep the stack like really tight, may spawn inside the middle of a block or spawn on the other side of a wall, which could result in people doing weird things. But this is a stack it's supposed to create. So this creates a little stack here, and they're not supposed to collide with each other. It's weirdly enough, that middle one is facing the wrong directions. This one's got me a little bit concerned if that missile actually fell pointing at a 9 down, or something else has happened a little funky with it. So I'll have to toy with that a little bit more because I've noticed that in previous testing and I can't confirm if it's actually correct or not. Because we saw the missile come right down and it looked pretty good. But let's go ahead and I'm going to go back into the entity and I'm going to turn the motion back on. I have this here just purely so I can turn it on and off. I even updated the look helper here purely so I can do this. So for those other modders who aren't really familiar with the look, this is designed in Mojang's code to tell you where an entity AI is pointing its head at, so you can do that debug. So that debug blue line is what this is. It took me a little bit of time to find it. Unfortunately, for some reason, Mojang's world space and stuff are kind of like weird. So you see some notes here where I was doing some weird shenanigans here. I don't actually need those anymore, but I've got it set up now. So it's going to take my motion vector and it's going to give me like the magnitude here. I actually could leave this at different magnitude values because it would still work. It would just give me a longer blue line, which actually has some advantages to it. I actually want to start putting more debug here information later, but we'll go ahead and reload this because you already saw it kind of fall there. And we'll go ahead and call it in and let it work as normal. And you'll see how it kind of behaves on that regard. I still need to add parachute support and stuff to this so that these fall a lot slower. So if you burst them from a higher altitude, they would spread a lot faster. Or well, more specifically, they wouldn't fall very fast, so they give more time to spread, allowing you to cover a larger area. Because in this case, they're mostly just going to spread out like that. And it looks like they actually were colliding with each other, which they're not supposed to do. So there's a little bit more work to do when it comes to the stacking behavior. Actually, I think I know what happened there. I have not updated the motion vector yet because I took away the old code for the spread and did not put the motion vector back in. So I'm going to go work on that, leave this video here, and I'll come back when we get this more closer to done so you can see the different results and how this is going to behave, and probably, hopefully, even some changes to the terminal launching the system, so that way you can control this detection height better without having to manually set the lock height and everything.